Okay, everyone, well, welcome. My name is Melissa. I am the head of community at ApeWorks. So we're a Python-based developer framework for developing smart contracts, deploying, compiling, basically Web3 infrastructure. I guess I got my start into Web3 and media from the NFT space and writing about it from a lifestyle perspective. So I have 3 publications. Violet Summerzine, which is my urban literary magazine. And then I have Crypto in a City, where I just talk about everything crypto related, what conferences I'm going to, what new tokens are out. And I have my GitHub link because I contribute to the ApeWorks framework. So we're going to be learning just the basics of blockchain and where it came from, proof of work versus proof of stake, miners and mempools, some hashing, techniques, and then, or about hashing, digital identity, and then a brief overview of some of the basic blockchains. And then if we have time, we'll talk a little bit about side chains and other layers. So let's get started. Okay, so what is blockchain? So when I first started out in the blockchain space, I really learned about it from a supply chain angle, and it's essentially a digital ledger of transactions that is duplicated and distributed across the entire network of computer systems. So when we say decentralized, it's peer-to-peer because these blocks are managed by different computers. So I like to think of blockchain as a highway that never sleeps. And the miners or the toll workers on the blockchain are what keep it going. And the computers are connected in some way through these nodes. And so the first blockchain was founded by this guy named Nick Zerba. And he's a computer scientist, and he also studied cryptography. So just to go back a little bit more, so there's blockchain is all about digital objects, and these are the informations that can be stored on the blockchain. Anything that can be represented as a number can be represented and stored as data on the blockchain. So some of you guys, or some of you ladies, might have NFT projects right now that are represented on the blockchain. And that's kind of what caught the blockchain or these ideal Web3 mainstream, the artists. But there's so much more that can be represented on the blockchain, and we are still scratching the surface. So I like to say when I was starting out, I'm like, okay, I don't know what you guys are talking about. Like, explain to me like I'm 5. And so there's been many attempts to create digital money in the past, but they've all failed. Just like this guy, Nick Zerba, he tried to create some blockchain and digital money, but it failed because it was a prevailing trust issue, meaning a lot of people did not trust that this money was actually going to be sound, that it could be something that you could spend in other situations, and that people would actually it could actually be peer-to-peer. So if someone creates a new currency and they call it, I don't know, the X dollar, how can we trust that they won't give themselves $1 million or steal your X amount of dollars for themselves? So blockchain is really about trust, verification, and authentication. And it's auditable because it's on a digital ledger that cannot be duplicated. So going a little bit deeper, blockchain is basically a block, and these are chains. So even a small change in the previous block, and feel free to raise your hand too, even a small change in the previous block can change its hash and break the whole chain and make it difficult to tamper with data. So when we talk about, blockchain, it's the study of cryptography. And this is a communication technique that allows senders and an intended recipient receive their data in a way that's not going to be tampered with. So as you can see, this hash is represented as it's cryptography. And sorry, my screen is a little crazy right now. Can't see. So this is the first block. Every time there's a first block, we call it the Genesis block. And then the second block is, the second block, and it's denoted as a specific hash. So no 2 hashes can be the same, but the previous hash has to stay the same. So this is kind of a scenario what a blockchain could look like. And when we speak about blockchain, I'm speaking about one of the first blockchains, which is the Bitcoin blockchain. And we'll get into another blockchain, which we probably all know, which is Ethereum. So what does a blockchain actually look like? So like I said in a previous slide, a blockchain is just a scenario of blocks. We have the SHA-256, which is denoted as our Genesis blocks. Then we have our nonces, which is our hash. And then within it is a set of data. So in this formula or this scenario, I put these numbers, or excuse me, these alphabets to be denoted as sort of wallet addresses. And then these numbers are what's in the wallet address. So if A equals 9, B equals 8, C equals 15, D equals 11, and E equals 17, then this is the TX is the transaction. And this is kind of similar to what you would see in a blockchain that without the code. So this transaction, if E gives B 1 coin and C gives E 6 coins, just so you guys are aware, how many coins does E have if E gives B 1 coin? If you look over there, you might be able to tell from this. Does anybody know? So basically, if E gives B 1 coin, that means E has 22 coins and B has 9 coins. So that's because E gave B 1 coin and B had 8 coins. So it's basically a set of mathematical equations. And when you're, really going into it, and if you don't like math, you're really going to understand why math is such the pinnacle of blockchain, because it's just pure math at this point. So a lot of the blockchain engineers that I work with, or you might come across, are mathematicians. And we like to say that blockchain engineers don't exist because it's just a bunch of math at the end of the day. But I didn't want to get too deep on it because sometimes it's taxing on my part. But this is just what these 3 blocks can represent, and you can't go back to the second block. So this is really, these numbers up here denote these transactions here, and then it just goes on and on and on. So when you think about it, when you're sharing coins, it's really about, okay, how much information is in one block, and then how that information goes to the next block. I see someone's hand is up. Can you say your name and
yeah, yes,
your question?
Sorry, it's Alison.
Hi, Alison.
I guess, hi there, and this is the best I've heard it explained. So I like all the numbers, but I'm not a numbers person. But surely you run out of numbers eventually. That's if A equals this and B, and you're swapping and changing the money, surely all the alphabet letters run out eventually. I don't know if that makes sense.
It does make sense. So the alphabet, I only use alphabet numbers to denote wallet addresses. So do you have a wallet address?
Yes. Yeah, okay. All right. So the A would be my wallet address, and B would be yours, and C would be someone else's.
C would be Valentina's, and D could be Supreet's. And so I only use that because it's kind of, it made it easier to put it in the box or whatever. But your second part of the question, so if you heard of Bitcoin, and we'll get to Bitcoin, there's only 21 million coins that can be mined and can exist. So it's a finite number of coins. So when you talk about, there's only a certain amount of coins that could be denoted. Now there can be a lot more wallet addresses in Bitcoin, but there's not that many coins. So that's where the math comes in. And then also in Ethereum, it's an infinite number of wallets, but there's smart contracts in that. So we'll get a little bit more deeper into that closer down the presentation, but great question, Allison. Okay, so I talked a little bit about hash functions in my previous slide, and hash functions. So what is a hash function? So hash functions are used for proof of work consensus algorithms. So proof of work, meaning that the miners or the people that are doing these equations are showing their work. So that means each block has some miner that's showing the work that says, okay, this is correct. A gave B this type of these coins, and it's denoted in, it's denoted in this block. And now we can go to the next block because we made consensus on the previous block. Hash functions can also protect your data. So IPFS, it means interplanetary file system. So it's just a long word for like a decentralized file, Google Drive, basically. And it protects your data. So if you have an NFT, the JPEG, the image of your NFT exists on decentralized Google Drive. So that means that someone can't, swap your NFT for like, a derogatory like pick, because I've seen that happen before where people are like, oh, okay, so they can't tamper with your data. A hash function also has signatures to sign transactions. So not everything on a blockchain has to be a cryptocurrency or coin related kind of function. It could be for DAOs, which are decentralized autonomous organization. It could just be like, every time you sign into your wallet address on Coinbase, I don't know if you have a wallet address, but every time you sign into a wallet, so you'll get like something like, okay, did you make this transaction? That's a signed transaction when you look on your wallet. When you look on your wallet receipts, you could just have signed transactions without anything, sending anything. Another thing it does is enable secured store of data such as passwords. So if you have, for example, a document or PDF that you want to, encrypt, that encrypted code can be a hash function. So when we get more into more autonomy and relying less on centralized systems, these hash functions can exist for multiple utilities. So that's kind of what a hash function is, and it's a cryptographic set of words, letters or numbers. So we just talked a little bit about hash functions and how blockchains kind of work when it comes to a Bitcoin blockchain and also the first blockchains. In 2022, there's hundreds of blockchains that exist, like not just Bitcoin and Ethereum and maybe Solana. There's tons of them that exist. And one of the key characteristics of these blockchains are proof of work and proof of stake. So some of the earlier forms of blockchains are characterized as proof of work. So their miners work to solve a cryptographer puzzle. So these puzzles, it's basically they solve these puzzles as hash functions to prove their work, and they get rewarded when they prove these cryptography puzzles. So when you think about blockchain, every time you buy, or for example, when Bitcoin was first came out in like 2010, there wasn't an exchange like Coinbase to go online and buy like 2 Bitcoins. You actually had to go into like a Starbucks or a coffee shop, and it was really peer-to-peer. But before that, before you could get your Bitcoin, there would be a miner, there would be a node operator on the other opposite end of the screen solving these puzzles to get your 3 Bitcoins into your wallet. And that means it was proof of work. So every 2 weeks, the blockchain adjusts the difficulty level of these puzzles. The more miners online, the more difficult it becomes. So right now, like I would say there's more machine miners, like Compass Mining, which is a company that you could just buy a mining rig for like $10,000 and someone could mine it for you, which means there's more competition. And every time there's more competition, there's less rewards for the miners. So when Bitcoin was just starting out, or when Bitcoin was at 2 million and it was still like 18 million to be mined, every time a miner mined a transaction or block, they got like 2 or 3 Bitcoins, like so many Bitcoins. But right now it just goes down. It just decreases as the Bitcoins are mined. And the proof of work functionality makes it harder to tamper with the chain, because there's always a checks and balance. There's always a computer that's making sure that that miner is not, a machine learning. I remember like some of the earlier conversations of Bitcoin, people would ask, well, what if machine learning comes in and tries to mine or solve the equation, to steal Bitcoin? And every 2 weeks, the blockchain is adjusted to another level of difficulty. So it just makes it harder for even machine learning to tamper with the chain, because there's always somebody that's going to be like, wait a minute, that's not what I have on my computer. And then somebody in China who has another computer is like, oh, well, I mined this, block 2 minutes ago, and that's not what I had. So it makes it even harder for machine learning to steal your Bitcoins. The next, I guess, technique for mining or keeping up with a blockchain is proof of stake. And it's basically what it means, the staking. It means the miners develop a reputation based on a number of coins that they own, or reputation in marketing. So proof of stake is really big with Solana, which is another blockchain. Ethereum is still proof of work. However, and a lot of our developers are miners right now. However, when Ethereum goes to 2.0, you'll need 32 ETH to stake on the network to be able to approve transactions. So that just means that you'll have like a pool of transactions, and you'll be in charge of mining these transactions at a later date. The engineers in the Ethereum Foundation or Solana, they think that this is going to be more scalable, and it would lower gas fees, because it would lower the amount of competition that's on chain at once, which is interesting. This is something that apparently it's on the test net now with Ethereum 2.0, but we haven't really seen it. We haven't really seen it in action, especially with all of this NFT activity, and then talks for real estate, other facets, other utilities of the blockchain. We haven't seen it in action just yet. So the case study is still being written, and I will keep you updated on hopefully my crypto in the city. But one thing to note, that exchanges like Coinbase and Gemini will be key stakers, because they have 32 plus ETH to stake, and people are going to want to stake their Ethereum or their transactions with reputable brands. So that's going to, I think for our end, since most of us are probably buying cryptocurrency off of Coinbase and Gemini, they're easy to trust. But when we get more into the industry, there's going to be other key stakers or validators that might be even more reputable than Coinbase. So TBD on that. So what makes a blockchain different than your bank? So you don't trust a stranger, so why would you trust a third party or third parties? So what makes a blockchain different is the cryptographic algorithms, because math never lies. So this is just an example of some code. I literally just took this from a virtual environment. And this basically this is again, like probably like a coin address. And then this is like the type of money or transaction that is being represented. So that's what makes the blockchain different. There's a set of there are a set of rules that eliminate the need to trust third parties and humans. So these are the rules, and every rule is always the same. So the rules never change. For example, an online bank helps you make online transactions right now. So one thing that when I was starting to get blockchain, I always say I move faster than the speed of fiat currency, because at one time I was in Paris and I was waiting for a check to clear, and it was a large check. It was probably like, I've never gotten a $10,000 check before, and I had like $2 in my bank account, and I'm stuck in Paris, and I put it in the bank, and they were like, oh, we need it to clear. And it took, I swear to God, it took like 10 days to clear. And it's like, what's happening in those 10 days? Well, the bank, whatever my bank was at that time, I think it was like Chase Bank, they were calling other banks, the Bank of America and Republic, to verify that these funds were real. And it was a paper check, by the way. So this is the third party. When the bank calls other people, they're relying on these third parties to verify that your funds are real and that the funds that the person gave you are actually validated. And that could take a long time. In blockchain, it takes roughly 10 minutes on a Bitcoin to mine transactions on Bitcoin. And then in Ethereum, it takes three minutes or less to mine a transaction. So that kind of makes a blockchain different. It's faster, it's more valid, the rules are on chain, and they're never going to change. When you're working with centralized systems, you never know, the rules can change. You're dealing with multiple parties and different personalities. And there's also there's also a possibility that the data can be tampered with. So just to sum up this slide, in blockchain, transactions are verified by these distributed nodes on the network. And within these rules, they always come to consensus because the rules don't change. So it's easier to make transactions in a quicker and safer way. So like I said, popular blockchain. So I mean, everyone kind of knows about the Bitcoin. It was founded in 2009 during the height of the financial crisis, 2008 financial crisis. It was founded by a group of people named Satoshi Nakamoto. When you go to these different conferences, like if you plan to go to a Ethereum conference or the Bitcoin Miami conference, pay attention to what people are saying. If you're like, oh, it's Satoshi Nakamoto. Some people might say it's a group of people. Some people might say it's a woman. But in general, like when this Bitcoin started, it was, it started as a white paper, and then on like Reddit, and it spread like wildfire. And it's peer-to-peer. So it really was like the age of the internet currency, when people really were just in distrust of a lot of different governments across the world, and they wanted a way to share and to send their money, and that wasn't being tampered with by some political turmoil. So Ethereum was founded by Vitalik Buterin in 2015. I need to switch that 2025. Sorry, guys. And Vitalik, actually, he was a writer. So he worked for Bitcoin Magazine. So Bitcoin Magazine, he started writing all these blogs, and he actually got paid in Bitcoin. So, and you could actually read his posts like online. I'll link it in the notes. But you could read Vitalik's posts. He started writing when he was like 17, and he was like, this is so cool. He was so inspired by, people around the world, from like Latin America and Venezuela and Colombia. When they were having turmoil, they started using Bitcoin in 2009. And so he started writing these essays. And there was talks to do a Bitcoin 2.0. But the community, or the people that were the core contributors who were involved in Bitcoin, they really didn't want anything to do. These are the Bitcoin maxes now. They're like, we don't want a Bitcoin 2.0. We like Bitcoin as it is. So Ethereum, Vitalik was like, no, I don't care. We need to evolve. We need innovation. Like, there's so much that's going on right now. So Vitalik, he you know, he like went to some like random part of, was it like Netherlands? I think it was like the Netherlands, but anyway, he goes to this random part, like puts himself in this cave and starts writing the white paper for Ethereum. And he sends it off. It wasn't even, it was like maybe like 4 pages. He sends it off, emails it to 10 people, and viral, people start sharing it. And he's like, at the end of the email, or like this white paper, he's like, you know, if you want to join me, come join me. I'm here. This is where I'll be at. So it goes viral, and that's how Ethereum starts. So the founding team of Ethereum, they start, you know, they go into this hacker house in Miami, actually, and they start building Ethereum. So that's why hacker houses are very native and relevant to the culture, because that's where that's where you build as a team in these like hacker houses. So even ApeWorks, like when I first started there, I didn't know anyone. We didn't meet until we got to our hacker house in San Diego, and we just started building all this like cool stuff and whatever. So I thought that was an interesting story. You could read more about it on Camila Rousseau's The Infinite Machine. It really talks about the culture of Ethereum. And then another blockchain that's really gaining steam is Solana. And this is a proof of history. So it's a public blockchain. It's eternal cryptocurrency. It's called Sol. And Solana achieves consensus using a proof of stake mechanism as well as proof of history. So you have to prove that on the blockchain that you were there at some point. So there's some ideas and some key frameworks that kind of mirror Solana. But I went to the Solana conference, and one thing to note that Solana started popping off because of NFTs. It was easier to produce NFTs. Developers were very like, there wasn't too many developers, but the developers that are on the network were really dedicated to building these NFTs and mining and deploying them on Solana. And so just to go back and kind of put this all together, with blockchain, there's no central authority. So there's not like a bank, there's not just 3 banks that you can put your money in, there's multiple. Anybody can be their own bank, really. It's verifiable and audible because it's on a public ledger, and each blockchain has their explorer, which I have a slide for that. This disintermediation, so there's not a third party. It's confidential. So even though your public key is something that lives on like a public facing blockchain, no one knows your private key, and your private key can't be duplicated. And it's robust because these blockchains, it can't easily be destroyed. It lives on a computer, and then because there's multiple nodes running, if your computer goes down, there's going to be like several other computers that have the information. And this is how we can verify an audit. So who's been on the Ethereum Etherscan before? Show of hands. Awesome. Yeah. So Etherscan is great. It's great for snooping. I love Etherscan. Like, so it's a public blockchain. Every blockchain has an explorer. So Bitcoin has an explorer. Solana's explorer is called Solana Beach, and this is where all the transactions live. If the blockchain doesn't have an explorer page, run. If you can't read it, run. Like, that's just like 101. If you can't see what this blockchain has on it, and they call themselves decentralized, then they're lying. So that's how you can verify an audit. So everything, you know, these filters or everything that's supposed to be on the blockchain should be on the public explorer and should be public facing. Okay, so how to read a blockchain, how to read Etherscan and best practice. So I would say for etherscan.io, oh, go ahead and say your name because I can't see your name.
Oh, sorry, Sharon. Is that
Hi,
me?
Sharon.
Hi,
Yes.
hi. I have a question. So are there any blockchains that you would say that we should stay away from then?
That is too, ask me later in Kanye West's. ask me later because so BitGold, so Nick Zerba, that guy that I was talking about, the computer scientist, he had his own digital currency, and it was through blockchain, but he had no miners. So people were just like spamming his blockchain. And the people who put money on that, they lost their money because it pretty much like went up in flames. Somebody like hacked the blockchain. So someone talks about reenacting BitGold run. If I would say like if the blockchain or the project doesn't have a white paper or some type of, you know, some type of like, you know, concept, I would say run. I'm going to show you in another slide all the blockchains that I've explored. But there's some other blockchains that's on my radar now. We can talk about that offline. That's since this is being recorded. But for Etherscan, I would say create an account. Like I have an account on Etherscan. It's called Blockchain Slayer, and you can actually report wallet addresses that, you know, maybe you got hacked. A few months ago, I got hacked, and I reported this one wallet address. So that, you know, I think with Etherscan, they try to be a little like they're trying to be community oriented. They have a great newsletter. So if you do put your email address and create an account on there, one of the things that you get is like, you know, what's going on their block. This is your digital ledger for anything Ethereum names or Ethereum related. But again, there's other blockchains. If you, for example, buy an NFT on OpenSea and you know you want to know where that's going, you can put your wallet address in the Etherscan to see exactly, you know, who's mining it, how much gas it costs, etc. If you buy an NFT on dropspace.art, which is another minting service, you know, sometimes they're a little slow with their transactions. You can always revert to Etherscan to see exactly where your transaction is, if it got held up, you know, with one of the miners in, you know, the mempool, etc. So that's just a little bit about like Etherscan. By now, what goes on chain? I would say any information that could be represented as a number, coins, ERC20 tokens, those can go on chain. NFTs, I say NFTs, non-fungible tokens, because that can mean art, that can mean real estate. There's talks with real estate deals being on chain. I've heard of like music NFTs on chain, supply chain data. So anything that might have to do with farming. There's a blockchain called ThankYou. That's really awesome. That's a supply chain, and they capture all the data of like where this coffee is coming. That can be on chain as well. So these slides are a little bit, so yeah, Bitcoin, like I said, 21 million can be mined every 10 minutes. That's kind of what their centralized theme is. They're really big on Bitcoin, and that's the blockchain for it. People can send you Bitcoin. Every transaction is recorded in a public list called the blockchain. And this makes it possible to trace the history of Bitcoin to stop people from spending coins they do not own, making copies, or undoing transactions. Ethereum, so we're not going to go too much into Ethereum. Blockchain 102 / how to write a smart contract is going to be more in depth with Ethereum. However, Blockchain 101, what I did wanted to say is that, you know, it's an infinite number that's coins in circulation. So every blockchain has a coin. Every blockchain that's kind of selling stuff has a coin at one point. It's powered by blockchain technology, by cryptocurrency. However, there's a different hash function. The Ethereum platform supports Ether in addition to a network of decentralized apps, also known as dApps, so decentralized dApps. So think of this as like, this is a Google Drive, and these are all, or this is a Apple phone, and these are all the apps that are on the phone. So anybody can make an app on Ethereum network. And as a cryptocurrency, Ethereum is the second market value only to Bitcoin. This is as of January 2022. You never know, there might be Dogecoin, might be like bigger than, Ethereum, but at the time of writing this, Ethereum is second largest market value. And like I said, some of the key features, a smart contract. So Vitalik, when he broke off from Bitcoin, he really was pushing this idea of smart contracts, something that are autonomous and they could do more to help the society, because right now Bitcoin, you can't really store data, you can only store coins. So that was his biggest qualm with breaking off from Bitcoin. Bitcoin 2.0 was supposed to store data. So he's the father of smart contracts, or cousin at this point, because he's like 26. It's transparent. So since smart contracts are developed under the blockchain technology, their code is visible and open to anyone who has interest. So if you go back to the Etherscan, I'm not going to stop sharing, but we can talk about the Etherscan later. If you go back to the Etherscan, there's actually a column where it has the code, and that's transparent. Like Google's not going to give you their code. Net-a-Porter is not going to give you their code. So with these smart contracts, anyone can read them. It's immutable. So that's one of the key characteristics. So they can't be modified by a third party. They can be duplicated, they can be forked, but they can't be modified. What's in the code is what's in the code. It's trustworthy because it's on a decentralized blockchain. It's deterministic because there's a set of rules that need to be followed. I can't see the chat.
I got
the
it.
time is almost, okay. So one of the questions that I always wanted to know is like, why do you pay gas fees with Ethereum and Bitcoin? So this is also known as transaction fees, rewarding the miners for securing the blockchain. One of the main reasons why you pay gas is to prevent spam. So the first blockchain that we talked about, Nick Zerba's BitGold, people spammed his blockchain because he didn't have miners. You can upload whatever you want. People are going to take it serious. You know, when you have to pay for something, you want to take it serious. Also with I just take it serious. Yeah, so you have to take it serious. I think I forgot what I was going to say, but oh, and it's rewarding. So with Web3, it's all about community and ownership and empowering the creator. So a lot of the developers are builders, they're creators in their own right. Not creators, yes, like artists, but they're really building the future, and they want to be rewarded. And at the end of the day, the Ethereum community is open source. And a lot of people who work for the Ethereum Foundation don't really get paid. I've talked to a bunch of, Ethereum community people who've been there since the beginning, and they don't really take a salary. They're there because they're really, really worried, but also dedicated to empowering and innovating the society all around. Like if you come across anyone that works for the Ethereum Foundation or related to that, maybe we can have a talk about that and have a roundtable. I think it's just so amazing talking to some of these people from the Ethereum Foundation, because a lot of the code exists on GitHub, and you'll see like the contributors. So that's one of the reasons why people pay gas fees, because they want to pay back some of these people that are building the future. So it's kind of, it's another way to decentralize employment. And the last thing I really want to talk about is your private keys versus your public keys. So within cryptography, you have the way that you interface with cryptography, the blockchain, is through your private key and your public key. So when you sign up for a wallet on, I don't know, MetaMask or Rainbow, you'll get your private key, and it could be like it's an asymmetrical encryption. And it's a type of encryption. There's two keys that are used. One key is used for your encryption, another key is used for your decryption. Your public key is your decryption. So your public key functioning is an alphanumeric C phrase that matches or syncs when the private and public keys are combined. So your private key, like don't ever give out your private key because it can't be recovered from a public address. So, and then another thing is your computer can't, you know, find out where your private key is, because again, that those hash functions, every time a block is mined, that block mines, you know, it's very random. So if you lose your wallet private key, that means you lose all the assets in there. And even with Bitcoin, which is notorious, like the beginnings of Bitcoin. I think my dad, he was saying, yeah, I bought some Bitcoin like 10 years ago. And I'm like, okay, well, those Bitcoins are lost in the ether. So I want to do some research on how many people actually are holding Bitcoin versus how many wallets have been abandoned. I don't know if we have any data scientists in here, but that would be a great project, like denoting like from a Bitcoin perspective, like, you know, how many private keys have been lost based on like wallet addresses that haven't had any activity. So that your private key and public key, basically, they are your digital signatures. So when you put a transaction onto the blockchain, this is like kind of like my makeshift blockchain, your public key equals your public address. So in ETH addresses, it starts out with 0x. In Bitcoin, it might be another set of numbers. I believe it's 24 numbers. And those numbers are your digital signatures. So if you log into your wallet from because you're holding your wallet address is your private, I guess, your private key. Those confirm the validity of the transaction. So basically, all you need to know is that your private key is molded from your public key and it's a digital signature. So once the computer realizes like, okay, this person's wallet address and is connected to this person's public key, it puts a check mark and it continues. I think in blockchain 102 and like getting into how the sauce is made, you're going to see how you interface with your public key in the actual code, because blockchain is literally like a bunch of code. And some of the code is written in Python, some of the code is written in Solidity, based on whatever blockchain that you might have, maybe Solana, you might have to, your developer, or if you start developing your own blockchain, it might be written in Rust, which is another code language. And this is your digital identity. So your wallet, I think Web3 is login with wallet. In Web1, it was just like go on AOL.com, right? And that's just, you know, that's it. You're on the internet. Web2, people started logging in with their email addresses or their Facebook. Web3 is going to be login with your wallet. And I think one of the big key factors that makes this really autonomous is because you can share what data you want to give away. You don't have to, you know, KYC yourself. Some sites that Web2 sites that you go on might need your address, your home address, your phone number. This is just your wallet, you know, like, so you can log in with a wallet just with your, you know, your dedicated wallet that you're logging into the internet yet versus your dedicated wallet that you're logging into your actual NFT or digital asset. So you can have multiple wallets within wallet addresses within you know, your autonomous banking lifestyle. And this is what I think is a new concept within blockchain, this idea of a digital identity. And it's a lot of people or a lot of companies are going to start adapting this. So the fact that you're taking this blockchain 101 course, you're figuring out like, okay, how is the sauce made? You know, what would I need to know? What are some key basics? And then how do I adapt this to my own ways that I can do go about the, you know, the world in a way that's more safer to me. So this is like, what can you do with your digital identity? So the internet service provider, at first it was just like from a centralized system, it's just a data center, and then you have your ISPs, and then you have your different apps, right? But in a decentralized system, you have multiple dApps, you have multiple ISPs, which could be blockchains, could be, different dApps on a blockchain to connect to different phones. So there's just different choices. There's more choices. And the fact that it's all connected on a blockchain that is auditable and verifiable, you can easily look up your address and figure out, where your address is going. You could transfer out your assets to another wallet. There's a lot of different ways that you can interact in a decentralized world than, having your email address or your phone number sold from, a third party. So that's why you get these robocalls. So this is just like something that I didn't do this actual module, but I always revert back to it because it's just really interesting when it comes to different concepts for DeFi. So I think this is for Sherry, like different blockchains. So there's so many different blockchains. We talked about Ethereum, Bitcoin, Solana. Harmony is another one. It runs on staking and validating. Tezos is another one. That's proof of history. It's a decentralized social media network. So imagine having all your tweets in one seed phrase or one seed phrase, and allowing you to take your tweets to multiple dApps within that network. I think might be an interesting concept. Again, this is still being worked on because we're still building Web3, but I think it's interesting to know about this stuff. So there's a lot of different blockchains. And then what can live on the blockchain? So this is the Avalanche blockchain. This is Dee Marie, you want to share your question before I go into this?
Yeah, so just kind of, I know you said they're still working on it, but can you go back to the slide before okay, so the decentralized social media.
Oh yeah, do you want to know about that? Because
what would so taking all your tweets to like, kind of what would that look like? Just so I can kind of visualize that like in my head.
Yeah, so basically the blockchain, so that means that because this blockchain Tezos is open source, you could essentially take the tweets of this Tezos blockchain and make your own blockchain. So for example, I don't know if you guys heard of BitClout, but it was really popping. Literally last year, I was on BitClout and I was tweeting stuff on BitClout. And then out of nowhere, the tweets, that BitClout was now turned into the Diamond app, right? So, but my tweets were already on the Diamond app, but it was just a different interface. So basically you could take with Twitter, like it is what it is. Like you can't take your tweets to another network, but in Tezos blockchain and decentralized blockchain, because it holds and stores the data, you can fork their blockchain, forking meaning duplicate it, make a whole new interface and say, okay, like I'm gonna write some rules and say, I only want tweets that deal with fashion. I only want content that deals with politics, and make a whole other blockchain, a whole other app pretty much. And that's kind of what BitClout and the Diamond Network did. Like everyone abandoned BitClout. So like, I stopped using BitClout for like literally 3 months. And then they were in Miami for Miami Hack Week. And then the guys are like, yeah, we got to get you on the Diamond app. So I'm like, there's like, did you log in? So I was like, yeah, I have my seed phrase. So I logged in with my seed phrase and voila, there's my tweets, but in a different interface. It was the weirdest shit. I was like, wow, like this is insane. And it's decentralized. So I only had about 100. It wasn't anything crazy. It was just like random thoughts and stuff. But yeah, I don't know if that answers your question. You didn't say your name, so I'm sorry. I can't see everyone's name on here.
Oh,
my view.
So I'm Dee Marie. So just to
Hey,
kind of
Dee Marie, yeah.
So to make a Web2 kind of analogy, is it kind of like how Meta is doing, like when I do a post on IG, they make it so that my post goes over to Facebook and wherever else. It's like the same post goes everywhere else, and I just have to post in one place, kind of, sort of. But that's like a Web2 kind of version, right?
Yeah, I think so. I think Yeah, because that's like an API. Yeah, exactly. However, like Meta has your data, so you can't take like the 2 million tweets or posts from Meta and take it to your own network. So with decentralized, it's decentralization means that like anybody can own it, you know? So with this Tezos, like anybody can fork their plugins, anybody can, or fork their data and make their own thing out of it. So yeah, it's kind of the same thing, I would say, but you can only do that with your tweet. You can't do that with like your club. Like if you wanted to like take your club members from Facebook, which is a huge problem. I've seen like a lot of people who have like 100,000 like members on their Facebook club, and all of a sudden their Facebook club goes down, and then they don't have any way of getting their followers. Or if you someone I know like had like 150K followers on like Instagram, and they have no way of getting their content back because that's owned by Instagram. With Tezos, anybody owns the content. So I could take my content and just make my own social network if I really wanted to, because of it's decentralized. So yeah, thanks Diva for bringing that question up. I don't know if does that help?
Yeah, it answers it, but you just said something that kind of prompted something else, but it's, I'll let you finish.
It just go down the rabbit hole. Honestly, like,
Yeah,
like
it's like,
that's
oh.
literally, it's like, you got to go down the rabbit hole. It's crazy. Cause like, you know, with blockchain, like this is everything that exists within like Avalanche, which the conference is right now. And I'm almost done. I have like 2 slides, but it's decentralized. So these are all the DeFi apps that exist in Avalanche. This is all the NFT and gaming. These are all the DAO tooling and the privacy, and people are literally using Avalanche, the blockchain, to make all these things. So blockchains are, I would like to call communities as well, because there's different personalities. Now, I don't know anybody from the Avalanche community. I'm starting, if I would have went to their blockchain, I'm like, okay, let's see what their vibe is. My favorite community, I would say, is Solana. Like, it's proof of stake, but the people involved are a little bit more, you know, refined. They don't look like they're not scammy, you know. I like Ethereum too. And this is the Ethereum blockchain. It's just a glimpse of everything that's going on Ethereum. But in general, I find the people in Ethereum to be not selfless, but they're very I can't describe the world, but you know, they're very grunge. Like if you guys went to the Ethereum conference, they're super grunge, and they're very like they philosophize a lot of stuff. So these are all the dApps on Ethereum, or what people are creating. So you probably see Rarible. You might have bought some NFTs on Rarible. You see MetaMask. These are all the wallets or asset management tooling, infrastructure. Hopefully we'll get some 8works in there. We were just recognized by the Ethereum Foundation. So that's cool. I need to redo this. We have some stable coins in here, Paxos, DAI, USD coin. So yeah, this is just everything that kind of exists within the Ethereum ecosystem. And my last slide, resources. So when I first started out, I was like, I got onboarded by some Bitcoin maxis. So they were like, you need to read the Bitcoin Standard. This is a free book. I bet if you tweet on Instagram or Twitter, like, does anybody have a free copy of a Bitcoin Standard? They would be happy to send it to you for free. So this is a free copy. Camila Russo, The Infinite Machine. It's an entertaining book about the Ethereum's community. I find it interesting. And it's just a Notion page. This is my personal Notion page. Every time I read something about crypto or Bitcoin, I put it in Notion. And then on my Crypto in the City column, I'm exploring the Near blockchain. I did not go into Near because I'm still learning. It's proof of stake right now, but it's interesting, and I kind of like their community so far. So I'll follow up with you, Sherry, on if it's like a good blockchain or not. And definitely follow 8 Frameworks. I'm head of community, so I'm behind the tweets and stuff. So we'll have some interesting things coming up, and we will be at NFT LA, Ethereum Amsterdam, and somewhere else. But thank you so much for tuning in. And if you have any questions, I'll be here to help.
So I'm going to stop recording and then I'll allow people to start asking questions freely.
Are you gonna also be at Miami NFT week?